On the graph, we want to show the boundary lines as either dotted for when we don't include. So in this case here, when we have greater than or less than, we want to show the dotted lines. But if we have the boundary lines as solid, that means that it's equal to, not just greater than or less than, it's also equal to that boundary line. So we get that solid line here, and we get the dotted line here. In example 1, it says, test the coordinate given in the inequality, then show the solution to the inequality on the graph. Well, we're going to test that coordinate. The coordinate is -1, +8. We're just going to test that in our inequality. So we get 2 times x is -1, minus 3 times y is 8, and we want to check that this is less than 9, and this is our test. So we get -2 minus 24 is less than or equal to 9. So we get -26 is less than or equal to 9. That's a check, so that is definitely part of our boundary area. Okay, so we're going to show that -1, +8, so 1, 2, 3, 4, 5, 6, 7, 8. That point there satisfies the boundary region. So we want to show this inequality on the graph. So what we're going to do is we're going to just draw the boundary line of this. So this is a linear equation, and we're going to show this boundary line as y equals mx plus b. So I'm just going to first of all solve for the y. So -3y, that's going to give me -2x plus 9. We're going to divide both sides by -3. Now be careful here, because when we divide by negative, we have to flip that side. And we end up with +2/3 as slope, and then -3 as the y-intercept. So then we draw that in. So there's -3, and we have slope of rise of 2, run of 3. So I can just show a few points here, okay, that indicate the coordinates along that line. Okay, and since it's greater than or equal to, we want to show this as a solid line through those points. And since y is greater than, we know that's going to be above this line. But we can also see by our test coordinate that our green test coordinate also satisfies that solution. So we can always test 0, 0. 0, 0 is always a very good number to test because it's easy to check. And if we put 0 in for y, 0 in for x, we get 0 is bigger than -3. That's a check for that. So we know that everything above is going to be part of the solution. So what I'm going to do then is I'm going to shade this whole area here. And this whole area above that line represents my solution, and up to and including that line. So there's our solution, boundary solution.